So today we're going to talk about the treasure hunt as a rock weathering measurement detector.
In this arc of measuring different soils at different time points, we're actually tracking different elements that are released from that rock. We're tracking these elements that are relatively sticky in the soil, elements such as titanium, nickel, chromium, and other elements that are present naturally in the rock. We're actually tracking those elements that remain in the topsoil, while also tracking other elements like magnesium and calcium flushing through the soil profile. So by understanding these different tracers, we're actually able to quantify how that rock has dissolved in a given time frame.
Is there a ratio about the sticky elements in the soil and the elements that's gonna dissolve? How is it gonna measure? Like, is it the higher the ratio, the better? Or
that's a good question. In this field, we call it signal to noise, and the soil is very complex. But at Lithos, we try to look for a 10x. The element should be at least 10x more than in the soil background.
You're listening to Bite Size Climate Tech, Season 3.
Hi, Ilya. Welcome to the show.
It's Lydia. Great to be here.
Bite Size Climate Tech is a bite-sized podcast that I talk to scientists and engineers like yourself to explain one climate tech concept each time. And Ilya is one of the leading figure in our carbon dioxide removal space. And you used to work at ION, and now you're working in Lithos. I'm super glad that you agreed to join us.
Great to be here, Lydia. I'm Elliot, and I'm currently head of research partnerships here at Lithos. I have a background in geochemistry and many aspects to understanding soils and different tracers that are abundant in natural systems.
Yeah, great. I think that's something that's very interesting. So today we're going to talk about the treasure hunt as a rock weathering measurement detector. If you can just take us the journey to rock weathering measurement.
Yeah, absolutely. So in this field of enhanced rock weathering as a carbon dioxide removal tool, there are a variety of different stages to actually determining empirically if the rock dissolves and thus how much carbon dioxide has been removed. And so just walking you through this process, there's first what we call a baseline soil sample, where we basically go out to the field and the Lithonian will stick a soil probe in the ground, and we will take a baseline soil sample before any rock has been spread on the field. Then we'll have actually, right after the rock is sprinkled on the field, we'll have a second measurement of that soil right after application. And then the last set of samples, what we call resamples, are after 6 months, 12 months, a year, monitoring how that rock has broken down and captured carbon. So in this arc of measuring different soils at different time points, we're actually tracking different elements that are released from that rock. We're tracking these elements that are relatively sticky in the soil, elements such as titanium, nickel, chromium, and other elements that are present naturally in the rock. We're actually tracking those elements that remain in the topsoil, while also tracking other elements like magnesium and calcium flushing through the soil profile. So by understanding these different tracers, we're actually able to quantify how that rock has dissolved in a given time frame.
Yeah, that's super interesting. So it's like someone on day 0, you haven't spread any rock yet, and then you have this GPS coordinate as well. You measure it once, and then on month 6, you return and measure another time to the different trace elements. Is there a ratio about the sticky elements in the soil and the elements that's gonna dissolve? How is it gonna measure? Like, is it the higher the ratio, the better? Or
so that's a good question. In this field, we call it signal to noise, and the soil is very complex. But at Lithos, we try to look for a 10x, at least a 10x signal to noise ratio in the rock. The element should be at least 10x more than in the soil background.
What is the signal? The signal is the sticky elements in the soil.
The signal will be the sticky elements as well as the tracer elements like the calcium, magnesium. We look for any signal that is 10x greater than what would be present in the soil naturally.
And then that means that the chemical reaction has happened. So then the CO2 has been requested.
Absolutely. So we look for as big of a delta or shifts in different signals compared to a background as possible.
The way that you can measure efficiently, is there any advanced tool that people are using on the field, or is it something that's existing?
Well, there are measurements and other artifacts that are taken at the field level, such as application maps, spreading maps that provide info, but the elements have to be measured themselves on fancy instruments, laser instruments called mass spectrometers, or what we call like optical emission spectrometers as well. But those are done in the laboratory setting. The actual in-field will look like a sampler collecting a soil sample and homogenizing it before it's analyzed.
Thanks for walking us through about this journey of someone who needs to go to the field and measure these signals.
How would you explain this to an 8-year-old?
If I were to explain this to an 8-year-old, maybe I would use the analogy from Fantastic Beasts, actually. There are these very furry, cute creatures known as nifflers who love shiny objects and shiny artifacts. They're obsessed with shiny artifacts. So if I were to describe this to an 8-year-old, I would say that I want to be a niffler and I want to find all the shiny data, like all the signal in the complex soil. I want to find all those and then share that with the world.
Yeah, it's like you can sense that shiny object, which is the signals in the soil. That's a great way to put it. I think everyone will remember that nifflers from the Fantastic Beasts. And then the next segment is we have a question from the previous guest, and his question is: so there's people who are feeling optimistic about the climate tech space and pessimistic. What do you feel about the future of the climate tech?
I am naturally an optimist, and one of the reasons I am optimistic about the future of climate technologies is actually a recent occurrence, which is in this past year and a half, the government, in the form of the Department of Energy, has begun to invest resources into things like the DOE CDR purchase prize. And this is a foreshadowing of potential governments moving in to provide investment and procurements of carbon credits in the future. And so I'm very excited to see the legitimization of CDR through agencies like the DOE.
It shows that the effort that now the top down, they're also taking efforts in speeding up the whole deployment of capital and also regulation.
Absolutely.
I'm also feeling hopeful whenever I talk to scientists like yourself. I know that there's people every day working to make this. Do you have a question that you want to leave to the next guest?
Yes. So as I focus on partnerships broadly, I would love to ask the next guest, how would you build greater collaboration between different CDR pathways?
What if the next guest is not working the CDR?
I would want to ask a question about broadening from one's niche specialty and asking how would one create greater collaboration and consensus to make your specific technology successful?
Great question. The one last segment is what brought you to work in climate?
Well, when I was young, I watched this film from 2006 called Inconvenient Truth by Al Gore.
If you look at the 10 hottest years ever measured, they've all occurred in the last 14 years. And the hottest of all was 2005.
I actually realized the enormity of that climate crisis from watching this documentary.
This is the biggest crisis in the history of this country.
I've since gone through my academic career and journey, received my PhD and learned about different geochemical processes, but ultimately have landed in this field of enhanced rock weathering to track and measure the carbon dioxide removal through clever detective work.
Yeah. I think that movie is maybe one of the few that everyone have watched and start to realize how urgent this. Let's hope that we can all make our own efforts and
let's make climate cool again.
Yes. Thank you.